welcome to lesson 5, which is about the union, intersection, disjoint and subset. As usual, let's begin with the warm-up. So we have a Venn diagram here, and you're asked from the diagram, find the n, which is the number of elements, to remind you, the n of p. So we're going to find the n of p first. So to do that, you've got to just count how many things in total are there in p. So we're assuming that these are all like, this indicates that there's 7 things in p and in only p, and 3 things in the intersect. So in total there are 7 plus 3 elements, which equals 10. How many elements are in q dash? So meaning not q. So by not q we just mean the outside of q. And outside of q you've got 7 and 4 elements. So equals 7 plus 4 equals 11 elements in total. So let's scroll down and see what the next question is. We're asked to find the number of elements in P union Q. So the union refers to all circles coloured in together. So the circles all coloured in together is a union. So as you can see, it's the union, it's got 7, 3 and 11. So 7 plus 3 plus 11 equals 21 elements in total. Next we have how many are in P but not Q. So P but not Q, as you can see, like, here's P, here's Q. So P but not Q is this part here. So it can't include the 4 because 4 is not part of P. It has to be in P but not Q. So it's just equal to 7. And scrolling down, let's see. How many elements are in Q but not P? So in Q but not P, you can see it's this one here. It's 11. So Q but not P, it's equal to 11. And how many are in neither P or Q? It means how many are around the outside, not in P or Q. So it's just 4. Now let's move on to the lesson. So lesson 5, union, intersection, disjoint and subset. So let's start by shading some regions of some Venn diagrams. Actually, we've actually kind of got the shaded regions already on these particular ones. We just need to label which regions are they. So the first 2 have been done for you. Some of them have been done. So obviously in the first one, nothing is shaded. And we can assume A and B continues. A and B. So in this one, obviously, the shaded one here is A. So therefore, in the second one, this shaded one here will be, of course, B. Now let's label the section that's been shaded for this particular one. So again, we've got A and B continuing. We assume it continues on like that. Here we have what's called the intersect. And so the way you label the intersect, you might remember, try to think. Yes, that's right. It is the upside down U is what you use to label the intersect. So you might just want to make a note that that is the intersect, is this part here. Moving on to the next one along. When all circles are completely shaded, that is called the union. And can you remember how we label the union? That's right, we use regular U. So upside down U for intersect and regular U for the union. So let's write that in. That is called the union. The union of A and B, whereas the previous one was the intersect of A and B. So you notice that these 2 here, this one here and this one here, they're the complement of each other. So meaning they're the opposites. So if this one is A union B, then you can call this one the complement of A union B. And we label that by putting A union B in brackets and putting a dash. So this refers to the complement of A union B. That's how you would say that in words if you're interested. And the last one has been done for you. So again, we assume we've got A and B here. So everything outside of B has been shaded here. So we can call that B dash. If you have to say that in words, that would be the complement of B. Complement of B, you can add that in there. And again, assuming we've got A and B here, you probably already had a guess at what this one would be. Yes, it would be A dash, which we can say is the complement of A. Everything outside of A. Basically think of it as not A. So let's move on to some trickier ones on the next page. Some trickier ones here. Slightly trickier. So assuming that it's still going A, B, A, B, and so on. A, B. So here it's saying the intersect of B dash. So everything that's outside of B has been shaded. That is also has to be A. So it's the B dash which intersects with A. So how do I know that? So in a way I kind of just looked at it and I kind of thought, okay, this set crescent, I refer to these as little moon crescents. This little moon set crescent is technically only A. So if you were to say it as a sentence, you could say it's only A. So it means everything that's outside of B, everything outside of B would include all of this as well though. But it's everything outside of B that intersects with A. That refers to this section here only. And moving right along, we've kind of given you a hint that it's something to do with an intersect. So notice it'll be the intersect of, you can call it the intersect of B if you want, which intersects with A dash this time. It's not wrong if you also had it the other way around, A dash intersecting with B. Similar to the other one, but I'd already put B dash in the first one here. So you had to put A in the second one. But here it doesn't matter, you could have had B intersect A dash or A dash intersect B. Because notice this little moon crescent section, that's everything in B that's not part of A. So A dash intersect B refers to, as a sentence, only B. That's how you would say that in a sentence. And the last one's quite complicated, so that's why we've tried to fill it in a little bit for you. So notice I've tried to indicate that the first part is the dash part. So it's everything that's outside of the intersect. So notice that, well, almost everything outside of the intersect. These crescents are everything outside of the intersect. So it's A intersect B dash. Just reminding you that means the intersect. A intersect B dash. But that would also, this part alone would include all this outside part as well. So A intersect B dash. So it's a part of that which intersects with the union part. A union B. Which makes sense because it's everything outside of this intersect here, everything outside of it is all out here, which intersects with the union part. So that's a little bit trickier though, an example of a harder one. But if you can remember that, that's a good thing. Now let's move on to some examples where we're actually going to shade ourselves. So here's one. So a little quick recap on some things we already kind of know. Fill in the missing two sections of each row. So the set of B, you can just assume it goes A, B, A, B, A, B, A, B. So if you were asked to shade the set of B, you would just shade the circle B. It's pretty straightforward. So just shade it better than I am. It's pretty bad. Okay, that'll do. So the symbol for the set of B, of course, just the letter B. And this next one, the hint we've given you is that it's A intersect B. So you could describe this as the intersect of A and B. When you do probability, you might also have the intersect described to you as A and B. A and B. So, because meaning that it's in both A and B simultaneously. And you probably realise already that the intersect is this little shaded part here. The centre part. The complement of A, we were just talking about that. The symbol for that would be A dash, A with an apostrophe. So if A is this circle here, we don't shade A, we instead shade everything outside of A. So we've got it's kind of a little bit tricky to shade, so you can kind of just shade it very carefully. It includes the outside of the union. So everything outside of A is shaded there. And this one here, that we've kind of shaded all through here, have a guess what you think that one is? You would be right, that is the union of A and B. Let's write that in here. It's the union instead of A and B. Later on when we do probability, you might have this area described to you as A or B. Whereas the intersect of A and B is A and B, the intersect of A and B is A or B. But you might not hear that language until you get up to probability. And remembering that the way we write the union in symbols, you put a little U in the middle. So that's a quick recap. Let's just save the work as we go. Now we're up to the next section where we're going to do some defining as well of a new section called Disjoint Sets. I'm not sure if you've heard of them before. So you also need to be aware of the following disjoint sets. So in the diagram you can see an example of some disjoint sets. So looking at that diagram, try to think what would be missing in the words above. Two sets are said to be disjoint if they have no elements in common. That is, they have no, have a guess? Yes, intersect. So they would have no intersect, or you could say their intersect is the something set. Try to think, what is the something set that has this symbol? The null set. So basically meaning that the intersect is the empty set. So it doesn't exist. There is no intersect because it's a null set. And so there, in the diagram below is an example of two disjoint sets. If there is some overlap between the sets, like in this little example here, and there is an intersect, that means that, for example, they have at least one element in common, like in this example they have the number 7 in common, then they are considered to be something disjoint. And don't use this word here, not, we say non-disjoint. That's why we have a hyphen there. So to be non-disjoint, that's an example here of a non-disjoint set. Whereas this is a disjoint set. So the intersect doesn't exist, or you could say the intersect is the null set. Now let's do some shading. So shade the given region on the corresponding Venn diagram. So we've drawn the Venn diagrams for you, whereas in the textbook you have to draw them yourself. But to make it a bit easier, we've drawn them in the notes. Shade the given region on the corresponding Venn diagram. So A, upside down UB, that's asking for the intersect of just A and B, not C as well. So for the intersect, think if you shaded all of A. So if you shaded all of A, let's do this for example, demonstrating this to you. Don't do this now because I'm just doing a demo. If you shaded all of A and all of B, try to think which section got shaded twice. And you'd be correct in thinking that the section shaded twice is this section right here. So don't shade anything just yet, because the answer is just the blue part. So for the intersect, if you shaded everything in A, everything in B, and you would then look to see which part was shaded twice, and it would be this section here. So this blue section is the intersect of A and B. You might have realised that already without shading twice. But that's a strategy you can use when you get to more complex examples. CUB stands for the union. So the union is easier to shade. Just means shade all of C and all of B and you're done. So let's shade all of C. Okay, just doing it roughly. Shading all of C, then shade all of B. There's no looking to see if there was anything shaded twice. It's just you shade all of C and shade all of B. So unions are easier to shade. Just shade everything that's been mentioned. All of X, C and all of B. So that one's done. Here we've got saying the union of A, B and C. So notice, don't shade anything yet, but the union of A, B and C is this little middle part here. Oh sorry, no that's not, that's the intersect. So the union, of A, B and C is all of this part here. So the union of A, B and C is all of this part here. So, but what they're asking, because it's got the dash here, it's saying the complement. So everything outside of the union. So you might want to say shade, shade everything outside of the union. That might be a good note to say. Everything outside of the union. So everything outside of the union will just be the outside of that. So it'll be this little outside region here. So I'll try to shade it nicely. I'll do it quickly so I don't bore you. Yep, so everything outside of the union is what you shade basically. And let's see, last one here is a bit tricky. A intersect C dash. So again, just reminding you, for the intersect, this is where you sort of shade everything and then see which one got shaded twice. So if you shaded all of A, so let's shade, just roughly do something that you can erase. Shade all of A in one colour maybe, and shade all the outside of C because it's C dash. So all the outside of C is all of this part here. You might not need to do this double shading thing, but if you get really stuck, this is a strategy for shading the intersects. So try to think, when you shaded all of A and all of the outside of C, which part got shaded twice? Like basically in green and red. You'd be correct in saying it was this little crescent here. So I'm going to erase that, and that's actually our answer. Another strategy that you can use for that is, so notice outside of C, that is part of A. That's one way you can think of it, if it's the intersect. If it was a union, you would just shade all of A and all of the outside of C. And all of the outside of C. There we go, so that one's done. And there's some more over the page. So in each of the Venn diagrams, shade the region indicated, so I haven't given you clues on this one though. So A, intersect B. You probably realise already intuitively, it's just the part that's both A and B. So this little intersect here. And here I said it in words, the complement of A intersect B. So in symbols, that would have been written A intersect B with brackets and a dash. You need the brackets, otherwise it's only B complement intersect A. So let's see. A intersect B dash it's just a complement of this red one. So it'll be everything that's outside of the red region in the intersect, in the above example. So everything outside of the intersect is all out here. So I definitely recommend you use erasable pen or pencil when you're doing these notes. And also when you're doing your textbook exercises and topic assignments. So that's the complement of A intersect B, the area outside of it. So now it's again the complement of A union B. So A union B dash. We need the brackets as well. So again, reminding you, the union would be this part, don't shade this part, because the complement of that would be, or the outside part here. So let's now shade the outside part. It can be a bit tricky shading it, so just do it nice and carefully. You go a lot slower than me, of course, when you do yours to make it look nicer. There you go. So that's the complement of the union, everything outside the union. Here again it's A dash. A dash in union with B. Remember, unions are easier to shade. Just shade everything in A dash and everything in B. I'm going to start by shading everything in B first. And now I'm going to shade everything in A dash, everything outside of A. And when it's a union, so long as you've shaded both of those regions, you've covered yourself. And notice that what's remaining is just the crescent, is not part of it. The crescent of A. And last one, we've got A in union with all of this together, which is B intersect C. So it might be a good idea, because it's a union one again, it's really easy. Just shade all of A. So I'll do first. I'm going to shade all of A and shade all of this, which is the intersect of B and C. Let's see. Yeah, the intersect of B and C. The intersect of B and C is this section here. So the overall shaded region is just all of A and the rest of the intersect of B and C, because it's in union. they're easy to shade. And the last one down here, sorry, I have the union for both of them. But be careful, we've put C dash on here. So unions are easy again, so just shade all of A. If you want, shade all of the next one, all of B, and they say in union with C dash. So C dash would be everything outside of C. So now let's shade everything outside of C. Don't shade any more that's inside of C. Because it's a union, it's a bit easier. We'll just shade all of those sections separately. So you notice the only part that's not shaded is this little part in here. Just undo that. So it looks correct. So now let's move on from shading. Let's move on to some Venn diagrams. So here's our first example. So given that the universe, the number in the universe is 32, so there's 32 elements in the universal set. The number in M is 13, the number in the intersect is 5, so it's always handy when we know the intersect because we tend to start with that. And the number in the union is 26. Draw a Venn diagram to represent this information. So it's only 2 circles this time. Don't forget your little U here. So 2 overlapping circles because we know that the intersect has 5 in them. And our 2 letters are M and N. Make sure to use capital letters. Let's start with the intersect first. That's always easier. So our intersect is 5. So that's been dealt with. We also know that the total number of M is 13. So this must be 8 because 8 plus 5 is 13. That gives us our M. But we don't know, we haven't been told how many in total are in M. But we can use this because we're told that the union remember is all circles together, is equal to 26. So we can work out this little region here by doing the union 26 minus 8 minus 5. And that gives us 13. So we know this little section here is 13. And you just got to see, is there anything outside here as well? Let's try that out. We know that the total must add up to 32, and 8 plus 5 plus 13 does not add up to 32. So we can work that part out by going 32 minus 8 minus 5 minus 13. And when we do that, we get 6. So this little part in the corner is equal to 6. So it's good to show a bit of working out around the side. So when you look back on it, you know what you were doing. From this Venn diagram, find the number in N. The number in N is, look in the circle, we've got 5 and 13. So there in total are 18 elements in N. And the next one is, find the number in the complement of the union. So complement, I might want to write that down. Complement of the union, meaning outside of the union. So outside of the union is just this little number here, 6. So it's already kind of been worked out, and you showed the math above already. So we can just say 6. And that's that one done. Now let's move on to the next example, where we're having to list sets. So it's important to understand what these symbols mean. So we're obviously dealing with natural numbers, positive whole numbers, and in our course it does include 0 now. So let the universal set equal all natural x, this set of x such that, we'll probably use a line instead, the set of x such that, set of natural x such that x is greater than or equal to 1 and less than 17. So it does include 1, but it does not include 17. So it's all the numbers from 1 to 16, all the positive natural whole numbers from 1 to 16. So easily enough, you're asked to list the elements of U. So let's do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Put the space there. And you're also told this information. P, Q, and R are subsets of U, of course, because U is a universal set. P is multiples of 4. So some of you might think, oh yes, the multiples of 4 go on forever, but we've got to do multiples of 4 within the union, 1 to 16. So we've only got 4 of them. We've got 4, 8, 12, and 16. So sometimes it's helpful to have this written down. Next one is factors of 36 that are part of this universal set up to 16. So that will be 1, 2, 3, 4, 6, 9, 12 are all the factors of 36, numbers that divide evenly into the number 36. And R is square numbers that are part of this universal set from 1 to 16. So don't forget 1 is a square number. Sometimes people forget that because 1 squared is 1. And 4, 9, 16 are the other square numbers. So having that written up there could be very useful for doing the rest of the questions. So this question here is asking for the intersect. Just 1 second. I'll just try to fix that. So it's asking for okay, we're back after I just paused it and had to close and open the file again. So we are here asking for the intersect of P, Q, and R. So the intersect of P, Q, and R is asking what numbers are in all 3 sets. So in all 3 sets, you might want to say. So in all 3 sets, if you look through the 3 sets we've got here, here, and here, try to think which number or numbers are in all 3 of them. And you might find there's only one number, the number 4 is in all of them. See 4, 4, and 4. There's no other numbers that are in all 3 sets. Describe in words the set P union Q. So just have a look up above. P, multiples of 4, Q, factors of 36. And remembering from one of the earlier pages that I just said in this lesson, if it's the union, we say the word or. So we could say it's multiples of 4, I'm saying it quickly, multiples of 4, or factors of 36. So anything within those 2 circles. Draw a Venn diagram to show the relationship between P, Q, and R, and write the elements of U in appropriate places in the Venn diagram. So it's got 3 circles this time. And now overlapping, they're all overlapping because, you know that because there is the number 4 in the center. So drawing a big square or rectangle, put the U there, and I tend to do the 3 circles like this. Make sure there is an overlap between all 3 of them. Let's label them P, Q, and R. I've labeled it around the other way. We know that it's good to work from the center outwards, and we know that the intersect of all 3 of them has the number 4 in it. What we then have to do is try to see what else you can work out. So let's see, in P and Q, do we have any others in common that are not part of R? And yes, we have 12. Another 12 is in common between P and Q. So we can put a 12 here. Look now in Q and R, see is there anything in common between Q and R apart from the number 4? And yes, there is. The number 1 and the number 9 is in both Q and R. So we can put 1 and 9 here. Then have a look at P and R. Are there any numbers in common apart from the number 4? P and R, yes, there is one number in common, 16. So you just have to look carefully and see if there's any others. And now this is easily enough to work out the rest. So R was the square numbers. So we've got all 4 square numbers listed in R already. P was the multiples of 4 up to 16, and there's 4 of them. There's 4, 8, 12, 16. So the number 8 goes out here. And in Q was the factors of 36, and so therefore the factors of 36, there's been 4 of them listed already, but there's 7 in total. So the ones we haven't listed are 2, 3, and 6. It's easy to think you've got all the numbers now, but you should have 16 numbers in total on your Venn diagram, because the universal set is all the numbers from 1 to 16. So the ones we're missing, you look and you say, okay, I've got 1, 2, 3, and 4. I don't have 5. I do have 6. I don't have 7. I do have 8. I do have 9. I don't have 10. or 11, but I do have 12. I don't have 13 or 14 or 15, but I do have 16. And then count how many elements you've got. You should have 16 in total. So that's a way you can double check in case you missed any. Now let's go on to the next example. It's quite a long lesson today. So given that Z is the set of integers, Q is a set of rational numbers, and R is a set of real numbers, just write down an element that belongs to R and Z. So the intersect of R and Z. And remembering in our real number diagram on page 10 of your notes booklet, we kind of had a general kind of Venn diagram. We've got the real numbers out here. You have irrational numbers out here on their own. The next one is rational numbers, is the next biggest set. And within rational numbers, you have the integers, positive and negative whole numbers. And within integers, you have the natural numbers. So that might be a helpful thing to look back on. So write down an element that belongs to the intersect of R and Z. And so Z is a subset of R anyway. So it could be any integer, e.g. any integer. And integers are just negative or positive whole numbers. So you just need one element. So you could have had like -2. You could have had 3. You could have 10 to the power of 12, because that's a whole number. You could have had square root of 25, because that's a whole number. You could have 4 over 2, or -4 over 2, that gives you a whole number. That's A answered. B. Write down an element that belongs to Q intersect Z dash. So it has to be rational, but not a whole number. So rational, but not a whole number. Rational, but not a whole number. So it could be anything that's a decimal or a fraction, for example, e.g. 2/3. You could have -0.123, so long as it's a terminating decimal, that kind of thing. Can't be a whole number. So write down an element that belongs to Q dash. So if Q is rational, then you can assume Q dash is irrational. Irrational numbers. Remember, irrational numbers can't be expressed as a fraction of integer, numerator or denominator. You can also think of them as numbers that have an infinite amount of non-recurring decimals. So examples of irrational numbers are like pi, surds like square root of 3. We could also have 2 root 5, for example. If you plug them in, you get a number that has an infinite amount of non-recurring decimals. E, exponential, is that number. That's another irrational number, similar to pi, root 7 over 2, and so on. So you just had to say an element, just one will do. Then you asked to use a Venn diagram to represent the sets Z, Q, and R. So we can use one similar to the one above, just notice they didn't ask for a Q dash. So don't worry about the Q dash. Let's draw our Venn diagram. And don't forget the U, in the habit of writing the U. So we've got our R, we've got our Q, and we've got our Z. So we weren't asked to include the natural numbers either. So R out here, Q, and Z. And we can finish up there. So we're just asked to represent Venn diagrams. We weren't asked to put any elements on there at all. So that one's finished. So the following Venn diagram shows the sets of it shows the sets of U, A, B, and C. And looking at that, you notice that A and B are intersecting, and C is a subset of B. But C is not a subset of A, but C is a subset of B. State whether the following statements are true or false for the information illustrated in the Venn diagrams. Give reasons. So A upside down C means the intersect. And they're saying that the intersect is equal to this symbol. So this symbol means the null set, or empty set, sometimes they call it. So if they're saying that the A intersect of C equals the null set, what they're meaning is that there is no intersect of A and C. So try to think, look at the diagram. Is it true? Is there any intersect between A and C? No, there's not. They're completely separate. They're like disjoint sets. So it's true, and you have to give reasons. You could say because there is no intersect between A and C. This next question here. C union B is equal to C. So it's good to just be in the habit of reminding ourselves. So saying that C union B means if you shaded all of C and all of B. So when you shade all of C and all of B, does that give you just set C? No, it doesn't. Clearly it gives you set B. So that is false. But remember, we have to give reasons. So we can say as if you shade, for example, all of C and all of B, you get B, not C. So that could be some kind of reasoning. Now let's scroll down. What is the next question? C is a subset of A union B. So you might want to remember this sideways little c means is a subset of, is included within. So C is a subset of A union B. So A union B is just the two circles together. And have a look at the diagram. Is C a subset of those two circles? And looking above, yes, C is included inside B, so C is then automatically a subset of the whole union A and B. So that is true, as C is a subset of this. And by this I mean that. That will do for now. The last one is A is a subset of. So is a subset of not C. So that's a bit tricky. So let's look at the Venn diagram. A is a subset of not C. So not C is all of this outside of C. All of the outside of C. And A, as you can see, is being shaded when we shade all of that. So A definitely is a subset of not C because it's included in the set of everything outside of C. So let's write that down. That is true, as A is contained within the region known as C dash, which means outside of C. Next one, as we move along to the last two examples, the sets of the universal set P, parallelograms, R, rectangles, and S, squares, are defined as follows. So you can see all that there. Draw a Venn diagram illustrating the relationships between the above sets. So they just want to draw it spatially. You don't need to put any elements in there. Draw your Venn diagram, write your U. So when you think of it, parallelograms is kind of the big, more universal set. So parallelograms, unless it's an irregular kind of thing, or a kite, for example, or a trapezoid, generally they're parallelograms. For example, rectangles and squares are all types of parallelograms. They're just special types of parallelograms. So the next most specific one would be rectangles. Because rectangles are just generally four-sided shapes which have two pairs of parallel sides and four right angles. The next one inside there would be squares. As you think of it, squares are special types of rectangles. So like rectangles, they're four-sided, they have two pairs of parallel sides, they have four right angles, but they have an extra attribute, which is that all four sides are equal. So if you need to give some reasoning, you can say, e.g., a rectangle is a special type of parallelogram. A parallelogram is just a four-sided shape with two pairs of parallel sides. You could also say that a square is a special type of rectangle, and you could write that down too if you wanted to. So you just copy this Venn diagram again, and for each of the examples, do some shading. So let's copy that Venn diagram. So we can just do it roughly, because we just asked to do a bit of shading. So we've got our P, we've got our R, and we've got our S. Don't forget your U. So P, R, S. And you're asked to shade everything outside of the union. So everything outside union of P and S. So everything outside of P or S. So everything outside of P or S, S is already a subset of P, so everything outside of P or S, basically think the union would have been the inside of P, because it would have been everything in P and everything in S, so the union would have been inside the circle of P, so the complement has to be outside the circle of P. And the last one, we've got R in union with S, which intersects with P. So we've got to copy the Venn diagram again first. Let's do that. Copy that roughly. The union, so we've got our universal set P, R, and S. So let's see. Everything that's in the union of R and S. So the union of R and S is basically just this part here, so don't shade anything yet. And which intersects with P. So which part of that intersects with P? It just turns out it's, let's see, which part of that intersects with P? Which part got shaded twice when we're doing the intersection? So which part shaded twice? Have a look on the diagram and try to see which part has got red and green on it. It's this part here. So I'm just going to undo that shading. A bit messy. So hopefully you didn't shade it, or you did in something erasable. U, so let's do P, R and S. So the answer is just everything inside of R. That was the part that got shaded twice. Now onto the last page. Nice and quick. So in the Venn diagram below, luckily it's been drawn for you, A, B and C are subsets of the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. And have all the numbers been listed? Let's see. We've got 1, 2, 3, 4, let's see, 5, 6, 7, 8, 9. So we're kind of missing 5 and 6, aren't we? Oh no, it's fine, because you might have thought, like me, that it was 1, 2, 3, 4, 5, 6, 7, 8, 9, but it's not. It's 1, 2, 3, 4, 6, 7, 8, 9. So it's fine that we're kind of missing 5, but we do have 6 and 6. So it's always good to check, like, do you have all the numbers in this Venn diagram? Have they left some off just to trick you? So that was one that was kind of designed to trick. It was meant to make you think that the number 5 should be in there as well, but it's not. So list the elements in each of the following sets. A union B, so just remind yourself that's a union. Let's see, A union B, if you want, you can do a light shading of it. A union B, if you like. So which elements? We're asked to list the elements that are in that set. So it's 1, 3, 4, 7, 8, 9. Just have a look, have you got the same amount of numbers that we've listed? So I said, always good to use erasable stuff. A intersect B intersects C. That's always easy, that's just this little intersect part here. So that is the number 9. So we're just listing elements, we're not counting. We're not asking for the end of something. So we're not counting, so it is just the number 9. Next one along, we're asked for A dash intersect C in union with B. So union is pretty easy. And the union with B, it's everything in B. So you could list 3, 9, 7 if you want. 3, 9, 7, which intersects with this part. A dash, which is in union with, this part. A dash intersection C. So let's think. A dash is everything outside of A, and we want everything outside of A that intersects with C. And that's these numbers. So we've also got to include, oops, I shouldn't have closed the set, so hopefully you didn't. So there's more numbers. It includes the number 6, because 7 was already included. And so that's the answer there. And that's pretty much the end of the lesson for lesson 5.